Good afternoon, everyone. My name is Rashmita, and I'm the event planner for Microsoft Reactor India. I welcome you all to another episode from the AI Spark series. Let's welcome our speakers, Vinayak and Shreyan, who will host this series. But before we start the session, I would request you all to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat section is open throughout, and we do encourage you all to participate. Our speakers will answer all your questions during the session, so please feel free to drop all your questions in the chat section. With this, let me bring in Vinayak and Shreyan into the stream, and thank you all once again for joining us. Enjoy the session. Over to you.
Thanks. Thanks, Rashmita. Welcome, Shreyan. Welcome everyone to another session of AI Sparks. As we promised last time, me and Shreyan are going to talk and demo and explain, how embedding models work and how do we build a RAG application. We will have the sample code as well, and this is a series. If you are the first time, if you are visiting or seeing this series, this is a six-part series. This is the third episode. It's running from Feb 13 to April 24th. um, Let me just go to the session. So, as I said, I'm Vinayak Hegde. I'm principal AI advocate at Microsoft. Shriyan is a software developer at KPMG, and together we are going to talk about embedding models and building a RAG app. So this is a series, as I was talking about. We have already done two sessions. The first one we actually talked about the AI toolkit and the feature walkthrough, and the second one we did a short introduction to SLMs and local models with use cases. And the third one we kind of going to build upon what we have learned in the first two sessions. So if you missed the first two sessions, my request would be go back and look at the earlier two sessions because they give some of the context necessary for this session as well. So this is the third session. If you have only registered for this episode, the QR code on your screen actually will take you to the series page, and you can register for individual ones. Or my suggestion would be to register for the entire series, so you'll get reminders, and then you can look at other kind of uh, topics as well. So with that, this is the agenda that we're going to talk. We have for the day. As I said, we're going to heavily focus on embedding models, how they are different from LLMs. We are going to do a demo of embedding models. Then we're going to talk about RAG, or Retrieval-Augmented Generation. We'll talk a little bit about the use cases, and then we'll show you a sample application that we have built using RAG, and demo it, and then you can try it out on your own. Also, we'll point you to the blog post that goes into detail about these implementations. In this session, we'll cover more of the concepts, and we'll cover more of the demos in that sense. So without further ado, let me talk about embedding models. So what are embedding models? So embedding models are different to LLMs. Shreyan, can you just maybe mute yourself because I'm getting a little bit of feedback? Okay, thank you so much. So embedding models convert text or other data into numerical vector representations. These numerical vector representations are called embeddings. They capture the semantic meaning of the text. And an embedding model, essentially what it does is it takes words, phrases, documents, and even other data. For example, it could be images or other kind of modalities as well, and takes that and converts it into a higher dimensional vector space where semantically similar positions are positioned closely together. So we'll talk about this a little bit later in the talk, where we can see this visually. And this dense vector representation enable machines to understand semantic relationships, right? So machines understand numbers, we understand like human language, and embedding models is a way to convert human language or text or any other modality that we have like images into a machine representable format that can be understood by the computer. And this is essentially what embedding models do. So what do? They take the inputs, as I said, words, sentences, documents, and convert them into numerical vectors. When they do so, they preserve the semantic meaning. So similar inputs have like closer embeddings. They also enable efficient search, recommendation, clustering, and classification. So typically, words that are like synonyms or closely related together will cluster around a similar point in the vector space. And then also they can be used for classification. So let's see a 3D view. By the way, this is a collapse 3D view. A vector's space is multi-dimensional, right? So it is not necessary that it will be 3D. It could be n-dimensional vector, and every dimension can represent a different kind of form, right? So as you can see, related words. Let's say if you take related words such as child and mother, right? Mother and child are closely related, and often they will appear similar point and text. A mother is also a woman, right? So you can see that mother and woman are very close together in the semantic space, right? It's kind of hard to represent this in a 2D space or even a 3D space, but essentially this is what it is, right? Man and woman are kind of opposite to each other, but they also represent the same concept, which is like gender and humans. Similarly, you can see like a common word like dog. Now, dogs are also related to wolves because at some point, wolves. Uh, it is believed that wolves were like domesticated, and then we kind of have dogs who are kind of related to the canine species because both of them are part of the canine family. Whereas the cat is also a pet and hence related to the dog, but it is quite far from wolf because they are not part of the same family, right? So a dog is related to wolf because yes, I mean there is a lineage there, and dog is also a pet, and hence cat and dog are also related. Now we take something totally different, like say apple or banana, both are fruits. They are closely related together, but they're still very different from animals or humans, right? So what the visual representation of vector space does is that um, uh, um, it clusters similar kind of concepts together. So when I say vector, so this is how a vector would look like, right? So you give an embedding model a word such as dog, cat, walk, Europe. It could be so here when we went back, we looked at mostly like nouns and concepts, right? But it need not just be that. It can be prepositions. It can be like at. It can be um, ad, um, yeah, adverbs like obviously it could be country or like continents like Europe or regions like Europe. It could be actions or verbs like walk and dog, cat, right? So it takes this representation, converts them into like a array of numbers or a vector representation, and then each of them has like semantic meaning very closely attached to the embedding model. So, what are the popular examples of embedding models? And the reason we are talking about embedding models will become very obvious and how they're different when we start actually looking at the applications in RAG, right? So, popular embedding models, which maybe some of you might have looked at, are like text embedding 3 small, text embedding 3 large. ADA 002 is another one. There's also BERT and its variations such as sentence BERT, BERT as a service. There's GLOVE or global vectors for word repetition. Word2Vec is one of the earlier ones, which was very popular. And then in the AI toolkit, we have the Cohere Embed version 3 multilingual, and we have the Cohere Embed version 3 specific to English as well, right? So these are the examples of embedding models. And essentially, if I were to kind of look at that, what they do is they take the word and then maybe like tokenize it and then eventually convert that into a vector, right? So this is the vectors is what machines understand, and any kind of operation that happens in the vector space. So when you choose a embedding model, how are you going to evaluate them, right? So there are multiple ways of evaluating them, right? So typically, because they convert a kind of natural language space into a vector space, semantically similar tasks or concepts should be able to be clustered closely together. Um, you can also take a very specific example of clustering or classification. For example, things related to sports, things related to say disasters, for examples, and we'll see that say typhoon and earthquake probably will be clustered a little bit closer as compared to say other things like say uh, um, um, tennis and golf and other things, right, which are sports. So if you take like two different concepts which are which kind of contain different kinds of type, you will see that they're kind of clustered together, and then hence you can do, and then you can do it for your domain also, because it need not be such a wide domain, it can be a very specific domain. There are also benchmarks that are available, such as MTEB, glue, super glue, centival, that are there. The other, in terms of performance, right, like dimensionality could be important. So lower dimensions are more efficient but may lose information. So the higher the dimensionality, the more the diversity can represent, but higher the dimensionality, those more sparse the representation. So you want to have a dense representation but also not lose information, right? So it's like a, you have to find what is typical the Goldilocks zone when it comes to the both the computational efficiency, which is the training and inference speed, as well as the dimensionality. So use cases for embedding models is, and I will see how this is used in the RAG pattern. But semantic search and document clustering are two top ones. We find relevant document based on meaning and not just keywords. So they can really represent higher level concepts, as I said, like related to sports, or you can say related to specific sports also. You can do group similar text together that are related to a concept. For example, if you are doing something related to compliance, all of the compliance related notices, guidelines can be specifically grouped together. If you are in a e-commerce kind of setup, then it can be used in recommendation system. Similarly, the opposite of that is anomaly detection. Something that is an outlier can be found, right? So you typically, uh, if your uh, if your input is expected to be closely clustered around a certain concept, you can have that together as well. You can also use it for duplicate detection, which is again like a kind of offshoot of similarity search, and you can also do text classification, which we have done before. And finally, we'll talk about augmented generation, where we find relevant concepts, relevant context for LLM responses. These are fragments of documents that are there, which can be then be pulled, and we'll see how do we do the chunking and other things in retrieval augmented generation. So these are the typical use cases for embedding models that are there. So in summary, before we go to the demo, embedding models generate fixed length numerical vectors. They focus on representation, not generation. This is where they're different from LLM models or any kind of language models. They're smaller and they're more specialized, and the output is machine readable, right? Whereas the output of LLMs is human readable. So they're specifically designed for taking human readable input and convert it into machine readable output. So with that, I would ask Rian if you can maybe quickly show a demo before we cover the concepts related to RAG.
Sure. Rashmita, can you share my screen? Yeah. So let's get started with the embeddings demo. So all this while we just learned what is vectors, how are they arranged, what are those things that get created. So I'll segregate this demo into two sections. So first one, I'll show how embeddings look like, and how do we generate one and keep. And the next part, we can create the vector, the database that we'll create. So we'll create the embeddings and we'll keep it ready for the upcoming part. Right, so first to begin with, so this is the code that I've written, a very simple code. So I'll just briefly go through what is done. So I've imported a model, a package called as Spacey, which actually provides me with some embedding models. This is an open source package for now, and I've taken pandas to create a data frame later on. Right, so I'm just loading the model. So instead of this, you can also load here ADA002 or any cloud model or models from Olama as well. For me, just to keep it very simple, I've just loaded a model here. This is my embedding model, right? And to install that, you have to just run this command that I've pasted here, right? So then I have defined a paragraph here in a TXT file, wherein I've just written a basic introduction of what is AI Toolkit, how does it do. So there's just hardly 2 lines in this paragraph, right? So this is the paragraph I'm loading here, and it's in UTF-8, so the encoding I'm referring. And then we are creating this process to paragraph using Spacey, right? So I'm doing that. Then I'm storing the vector representation, the one that Vinayak just showed, wherein there was a vector representation where there were a lot of numbers in an array, right? So that is what I'm storing in this one, right? And I'm iterating through that, and then I'm creating a data frame, right? So finally, once my data frame is ready, for me to see it, how do they look? I'm storing them into a CSV, right? So this is the paragraph again, whatever I've taken. So upon executing this code, right? So ideally, what it should do is it should give me a particular CSV file. Although I've already generated one, I want to generate a new one right now, right? So we have the CSV. So this is how typically our embeddings look, right? So that two lines that I just showed you, whatever I just had about AI toolkit, they are now embedded in this fashion that no one can understand except for the machines. So all these are relational, I would say, position in a 3D space, right? So they are arranged to me in this particular way. Our embedding models actually do this job for us, right? They do not do any other task. Instead, they help the LLMs to perform the further searches, right? So this is what Vinayak was referring to all this while. So now we have a practical view of how they look. It's all random numbers. I mean, if you try to read, you won't be able to understand what it is, but it has basically pointed out all the words and kept it in a particular space. So with this knowledge, now we can proceed and create a basic embeddings again with a let's say a model that I'm getting from a cloud, right? So again, to do that, I'm using GitHub models here. So just to show you how it looks, right? So in GitHub marketplace of models, you have these four models that are available to you, right? So OpenAI text embedding 3 small, OpenAI text embedding 3 large. These two have all of these models have a set token limit. So be sure to keep that in mind when you're working on it. This will work very well for a POC, but if you're moving for a product, then you can move to Azure Foundry portal and then get a subscription of the same and then move it into production, right? So we have these four. So for now, I am interested in using this one, OpenAI text embedding 3 small. So let's see how do we use that in our applications, right? So firstly, I'll import the packages. So I'm installing the OpenAI package here. So you can also use Azure Inference SDK as well to do this. But for now, I'm just to keep it very simple for the demo, I'm taking the most simplest way, right? And then I'm creating a env file. So this is my env file here, which I unfortunately cannot open because it has my key, right? So but when you create one, create your GitHub token or the key that you are having, it's a very good practice to store it in the env file, right? So I'm loading that here right now from my env file. So you can see my token and the endpoint and everything being loaded here. Okay. So you can see that my endpoint and the model name, I'm supplying it here, and the token is also being flown, right? So just to make sure, I can also print the token and see if that if my token is actually coming here or not. But I think there was a token here which I just removed right now. Then we are defining the client, right? So this is basically like the like the main guy who kind of talks to your API, right? So we'll have to define who's your particular client. So in my case, it is right now, since I'm choosing OpenAI, it is here OpenAI. In the next section, I'll show you how does it differ from this OpenAI, how does it change to OpenAI embeddings, which is from another open source library, right? So this is basically I'm starting to initiate the connection in very layman terms. I can say I'm trying to create a mediator in between who will kind of initiate the conversation from my code to the API, that is my OpenAI API that is hosted on the cloud, right? So this is that mediator who's there in between. Now what I'm doing, I'm just trying to, in my previous case, when we saw the embeddings using Spacey, what I did was I created a paragraph and I tried to do it, right? So now, just to again keep it very simple, I'm just keeping these phrases here, first phrase, second phrase, and third phrase as my input that needs to be embedded, and I'm passing my model name. So in this case, now you can see the change is that I'm using a cloud model instead of a model that I was using before. I was downloading and I was using it before, but now I'm going to a hybrid scenario, right? Now, there might be questions that why am I actually doing this, right? So it is always seen that the efficiency when it comes to a open AI based text embedding model for creating these embeddings is very, very, different when we compare it to kind of the open source models. It's not I would say a recommendation, but it's always better to kind of go with open source models. But uh, if it's really needed, or then always there is a thing to use cloud, right? So that is why I'm using cloud model here, and you can see that I'm just iterating over the items and I'm getting the response out. So if I execute this, let me execute it from the first. So I can print token, but I'm not doing it right now. And my client initialization is ready. So now I can see that these are the embeddings, right? These are the embeddings only for these three things that I've created. So now after this, what we do is we create these embeddings and then we have to store it somewhere, right? So I will maybe Vinayak, we can finish off the storing part as well right now using the Chroma.
Uh, yeah, you can finish the. So maybe you want to talk a little bit about the vector database, maybe in short, because
Sure.
just looking at the time. Yeah, and but we can finish that part as well, and then we'll explain, how it is useful in RAG and how vector source is slightly different.
Right. So now what we do is maybe right now what we have done is we have created the embeddings, and next part is to store them in a particular database, right? So here in the generative AI applications, we kind of have a specialized vector, I mean a database which is also called as the vector database. Again, we cannot get much into the details of that because that itself will be a separate session, but for now you can try to understand that this is a type of database that holds your embeddings, which helps the LLM later on to retrieve it from there, right? So now what we do is now we kind of create that database. Now why are we creating it? Because the embeddings here are of no use. If I keep it in my CSV, then also you can use it, no doubt. But the best way to use it is through a open source, or like let's say any vector database, right? So to do that, I'm just using Chroma DB here. So there are a lot of open source databases. There are a lot of cloud vector databases available. For this demo, I've chosen to go ahead with the open source database, which is also very popular among the developer community. So that is Chroma DB, right? So if you're choosing for, let's say, a cloud-based database, so you get more power in that. Like, let's say, for example, the Azure AI search service, right? That provides you with semantic search and many other features which you can use for sure. So if you're looking for something on the cloud, then I would definitely prefer going ahead with Azure AI search because it has a lot of features, and I've personally used it and I've seen the differences that come out in terms of the response quality. So if you're using, if you want to use that, then definitely go ahead and use that. You can find the documentation for that. So for now, let's go ahead with Chroma DB, right? So I'm just doing a pip install. I'm installing all the libraries that I need. And the next library that I'm using, which we'll talk about a lot in this particular session, is LangChain. So LangChain, I can say it's like a orchestrator library for your generative AI applications. So your generative AI models by themselves cannot do all this orchestrating part and things like that. So we need a framework for that, right? So let's say you want to develop an application out of it. So you would need some moving. There are a lot of moving parts into this. So we need some framework that handles all these moving parts that are there in your whole application life cycle. So that is where you have a lot of open source libraries available. One among them is LangChain. Then we also have semantic kernel, which we'll be talking about in the upcoming sessions as well. So for this one, to keep it very simple, to keep it very beginner friendly, we have taken LangChain, right? So LangChain OpenAI and LangChain community is what I'm installing. So once I'm done installing, I'm just importing the required modules. So for example, directory loader, PDF loader, Chroma, and all the other embedding things that you can see. So one difference at what I'm doing here from before, earlier I took a paragraph and I took one txt file. Now for a change, I'm taking this PDF file. Of course, you cannot read it here very well, but it is basically my AI toolkit's front page that I've just downloaded it as a PDF, right? So here I'm just giving the directory of that. So I'll meanwhile execute it when I'm explaining, right? So here I'm giving the directory. So I've placed it in docs and I've placed one PDF. So with this code, this is available to you on our GitHub as well. We have a GitHub repo where all this code you'll find it later on after the session as well. So you can follow it up from there. So I'm giving the documents path in my doc, so I can place multiple PDFs. Just for simplicity, I've placed one PDF here. And now the next part is to load the document and create the chunks, right? So why do I need to load the doc? Firstly is all those 10 or 15 set of documents, how much ever documents you have, I'm loading it and keeping it ready. The next part is, now let's say I have my document. Let's say one has 10 pages, other has 20 pages. When I create these embeddings, I just cannot blindly create all these embeddings, right? So because there's a context limit that your LLM also has, right? And also there is a response time that will depend on the number of the context that you send, the data that you send to the LLM. So we kind of restrict this, right? So we kind of improvise this by doing something called as chunking. Okay. So now what is chunking, right? Chunking is basically a approach, a strategy that is taken to kind of reduce the size of each of the context that is being sent. So let's say there is one page, I divide it into characters of 1,000, right? So 1,000 characters go in my first section, 1,000 go in my second section, and so on and so forth. So by this, what happens is I kind of have a control over the data that I send to the LLM. With this, the chances of hitting rate limit or the chances of increasing the time taken for searching, all of this is kind of reduced by this chunking approach, right? So that is where I'm doing the next part. I'm just splitting it into chunks, right? You can just visualize it as I'm taking a page and I'm cutting it into 4 or 5 different parts, and then I'm just keeping it together. So now what happens, my whole page is not sent. Instead of that, these cards that I've created, right? So these paper cuttings that I've done, so each card, the relevant card is sent to the LLM for further summarization or whatever it is. Now, who actually picks these cards? Who actually decides which card to pick? That is where again your embedding model comes in, right? So I'll just show a query how that card is also seen, right? For now, let me just do the chunking. So I've kept the chunk size as 1,000, and there is something called as chunk overlap. This I've kept it to 100. Right, so this is actually chunk sizes. Let's say I define what is chunk size. Now, what is chunk overlap? Chunk overlap is basically to keep the relation. Let's say my line ends with splitting these documents into chunk. This is my one line, right? And then there is here written documents. Just to keep a relation in between these two particular things and not to make them completely different from each other, what I do, I keep a slight overlap between these documents, so that if I read, I get to know, okay, there is something that is followed on the next part. It is like you might have read these storybooks or something where it says continued on page 2 or continued on page number 5. So you understand that there is something, there's a part of it which is still pending to be read on some other page. So this overlap actually does that to you, right? So it says that how much of that particular section should I overlap. So for example, here I've kept it the 100. So 100 uh, tokens or 100 characters, whatever they are, they will be overlapped in order to form a link between these two chunks that are formed, right? So again, I'm passing that to a recursive text character splitter, and then I'm returning the docs. So these are the two functions. Now I did not call them anywhere. If you have noticed, I just created my functions. Now I pass it on my documents, right? So let me run this, right? I think I have, yeah, this is also done. So now I'm just loading my documents. So as you can see, it has done loading the documents. It is saying one of one documents is loaded, and the time is very minimal because I'm just having one. Now I told you we'll split it, right? So let's see how much does it split it into. So here you can see it has split it into 12 chunks. So the one document, maybe I can show you that document as well. Give me a minute.
Yeah, I think we're almost to the end, no, of the demo. So
Yeah. Yeah, so this is my document, right? So you can see there are 6 pages, but it has converted that into 12 chunks, right? So this is the chunking that I've done. So after this, what I do, again, I told you we have a client, we have a middleman who talks, who's a mediator here in between your API and um, your application. So again, I've defined. So if you noticed earlier, just a few minutes back, I used OpenAI, but now I'm using OpenAI embeddings. Again, this is just to match the compatibility with your framework. So again, You should be very mindful of this when you use it. For now, I'm using this one, right? Then finally, I have to store it in my database. The whole purpose of doing this, I created the chunks. My chunks are ready here already, but they have my embeddings also will be ready in some time. But where do I store them, right? The storing is where the problem statement we had. So I'm storing it to Chroma database, right? So I'm defining the model and I'm giving the directory as this, right? So let's see how does it create a directory. Okay, so here if you see, there is AI toolkit, and you can see this library, and you can see this Chroma SQLite 3, right? So this is ready, and we have all these things which will be further used in the upcoming section. And now my database is ready. Let's have a test on it. How does the chunk look, right? So I'm just passing a query, what is AI toolkit, right? Because my whole part is around AI toolkit. So now we can see how do embeddings model actually have a search that Vinayak was referring to before, right? So it has a metadata and everything stored. So now let me run it. So now this time I'm getting it from my AI toolkit and not from a direct PDF, right? So the database I created, the AI toolkit database, I'm getting it from there. So let me just run this again. Right. So you can see this is the chunk, right? This is the chunk that had my answer. So it says author was this, creation date was this, time, and whatever it is. The file path is also given here. So I'll talk about this file path and all the other aspects when we have more, clarity on that when we talk about RAG. But yeah, for now you can see that it has fetched this chunk, which explains what is AI toolkit. Again, this was done by our embedding model, that is our text embedding ADA 0, embedding 3 large, right? So this is how chunks look, and this is how embeddings work, and that is how you create a vector database to store them. Vinayak, anything to add on to this?
No, Rashmita, if you can just move to the next, because we have created the embeddings, and if you just go back to my slides, then I'll explain the RAG and how this works in the context of RAG as well. Cool. So now we'll talk about retrieval augmented generation, right? So what is retrieval augmented generation? As the name says, retrieval augmented generation is a technique that enhances large language models by retrieving relevant information from external knowledge sources before generating responses, right? So now we have seen the pre-processing part, which Rian demonstrated, where you had the PDF document, you converted that into embeddings, and then now you're able to query the embeddings by sending it a query, right? So what he demonstrated was essentially the retrieval phase. So the retrieval phase, what it does, it's based on the user query, it finds the most relevant information from the knowledge sources. In this case, a vector database in ChromaDB, and it can have consist of various subtasks, right? Because this was very small demo application, we haven't gone into so much detail, but it can have subtasks such as query processing, semantic search, vector similarity. You can do some amount of filtering, ranking. You can also apply some kind of security kind of measures. Like for example, if the information is confidential and maybe some part of the organization have to may not may not have the permission to actually view that, then you can actually filter those out also. So you can also possibly use multiple data source as well to kind of do that. The augmentation takes this all of this, integrates that with the meta prompt, which is a system message, all of the context maybe around user actions, on the past user actions. So it does various subtasks such as context selection, context formatting, metadata integration, re-ranking, and ticks all of that and creates like a prompt, then which is then sent to the generation phase. So generation phase is the final phase of the RAG, where the response is based on the user query and the augmented context that were given from the metadata and the other context, plus the retrieval that we have done from the embedding phase. And we saw the retrieval phase in the embedding model as well, right? So it consists of tasks such as prompt construction, LLM processing. Many times, I think you will also require some amount of citation generation, right? Which document is coming from, which page is it coming from, which paragraph it is coming from. So all of that citation generation is done in the generation is done in the generation phase. You can also refine the response based on maybe certain parameters or certain stylistic guidelines. And based on the answer you get, you can also assign a confidence score, saying that how confident does the LLM feel based on the processing it has done, based on any kind of ranking that can answer the user query, right? Because in the case of LLMs and also in the case of RAG, the answers may not be exact; they might be approximate, and similarly, there can be some ambiguity in the document as well. So this is this is actually shown in the confidence scoring. So there are so why is an RAG architecture important, right? When compared to standalone LLM. So LLMs again have a fixed training date, right? So while LLMs have world knowledge, you will often see if you when you talk to the LLM, if you talk about current events, they may not have that data. If you talk to them about things that have happened after the training data was kind of crawled or collected, they will not have that. So that is the knowledge cutoff. It may also sometimes hallucinate if it does not have the answer. And but what RAG does, it because it is retrieving this information from actual sources, it grounds the responses in factual sources. Hence, you can do the citation as well, and kind of point back to the source from which it has generated the answer. There are also internal data sources and domain knowledge which a RAG can access, which may not be in the training data set of an LLM, right? For example, if you're in the healthcare industry, if you're in the finance industry, you may not have this kind of expertise. The model is very generalized. So to augment with your own private data, with your own proprietary data, or your own specific domain context, the RAG kind of extends the capabilities of the LLM to that particular domain, right? So obviously you have prompt engineering, system prompt, but they can only go so long. So the next kind of evolution to that would be using the RAG related things. So this is like a sample RAG architecture. I think we have demonstrated the first part, which is like the documentation processing. Shriyan demonstrated how to do ingestion, chunking, what is the purpose of chunking, the pre-processing if there is anything needed. Then you saw the embedding model. ChromaDB was the vector data store that we use, and then we indexed. And then eventually we sent it to the retrieval engine. We did a query processing, it did a similarity search and ranking, right? So I'll just keep on going back and forth to show you the actual diagram. So if I go here, this is kind of the architecture, and we had the data files, we passed the text, we chunked the text with some overlap, we then sent it to an embedding model, we generated the embeddings, and you saw the embeddings are like vector representations. Now all of these vector representations are then stored in the ChromaDB, and then the user does a query that is converted to embedding format, and then you pull out your data, right? So going back here, right, like mapping it to the phases that we said before, right? We came back to the retrieval engine, we did a query processing similarity search, we got the chunks, then the augmentation layer, which adds a extra context related to the user, the domain, the application, maybe what actions the user has performed in the past, all of the metadata, the system prompt, all of that is collected. Maybe the prompt can also be rewritten because the user may not have been given the best prompt. So prompt enhancement can also happen at this layer. And finally, then the response generation, any post processing or citation generation is done in the generation phase, and then that is shown back to the user in the query response. And that is what is shown in the lower part of the diagram, right? The user is sending a user query, and then it's converted to question embedding, then similar text chunks which you saw when Shriyan actually queried those information. Those are sent on the 5.3 SLM that are there on the AI toolkit, and then using the generative capabilities of the SLM, you are getting an answer in a human readable format, though the encodings themselves are in a machine readable format, right? So now you're taking your query, converting it into an embedding, querying the vector data store, getting embedding back, which is again now numerical or vector representation, and then the LLM is takes that input and then converts it into human readable format, right? So with that, we'll talk a little bit about the use cases that are there for RAG, and then we'll go on to the RAG demo. So these are the typical use cases. When you use RAG, you have enterprise search, finding information across internal documents, customer support, especially if a customer has had specific problems, or a series of customers have had specific problems. It can help in retrieving accurate information, right? For example, there is maybe an outage or there's a billing issue, and people already know that RAG can actually pull that information and automate some part of the customer support. Legal research, which requires citation, case law, regulations, any kind of earlier judgments, all of these can be pulled out when it comes to the legal research. What is your typical work the paralegal does in a legal firm. Similarly, any kind of medical literature for clinical questions, uh, with database of diseases, database of symptoms, it can augment the capability of a doctor, and kind of augment his ability to kind of map the symptoms to a disease, or even format what the doctor is writing into a format that can be understood by the machine, right? There are educational tools also. There are adaptive learning system, whether it is related to maybe social sciences or languages. I think brag can you kind of pull in a database, and from a knowledge source it can create those questions by yourself. So this all depends on the prompting. For example, in a educational tool you can have lots of different kind of syllabuses, and then based on that it can pull out the questions. Similarly, it can act as a research assistant, or even act in a financial market. um, we won't go into this into detail, but another traditional RAG has certain challenges, especially when the number of concepts and the relationships between either characters or entities, like is part of, is a member of, is related to. These kind of relationships are not captured really well in traditional RAG, because it is converted that into chunks, but sometimes the context between chunks or the relationship between chunks is lost. So what it combines is the power of knowledge graphs, and then it is able to combine the power of knowledge graphs and use that in the context of RAG to give much better interconnected data, which reduces the fragmented context which can happen with traditional RAG. So anything that has like large number of concepts, or large number of interdependencies, that can work really well. Example could be, if you are in a compliance kind of segment, or you are analyzing maybe like a literary output of a author, and you want to see how the different characters interact, what is their relationship. It cannot be kind of condensed in a specific context, but GraphRAG can do that. Like similarly in compliance, let's say you're building a restaurant, you need to know about building regulations, you need to know about fire regulations, you need to know about labor regulations. So if you're opening a restaurant, it can actually pull off all of this information in a format that you can understand in a maybe a chat interface or a search interface. So GraphRAG actually, scales more effectively, enhances semantic understanding, and reduces the fragmentation, especially in a multi-documented, multi-domain kind of research. So I have written a fairly detailed article on this, and it has more links to explore this. So you can go to aka.ms/g-rag, and you should find more information there. So before we go to the demo, I just want to summarize what we have learned so far in terms of RAG. So the power of RAG is the ability to combine the strengths of LLMs, because LLMs are knowledge, knowledge cutoffs and can hallucinate. They make it grounded, reliable, and have up-to-date knowledge from external sources, which typically an LLM training data set may not have. So integrates the best of both worlds, the flexibility and reasoning capabilities of LLMs, and also the language generation capability with the accuracy and specificity of IR, or information retrieval system, right? So it kind of uses the best parts of an LLM and then extends it world knowledge by using the embedding model, which we just saw, and Shreyan gave a demo of that. So with that, we'll just go to the demo. Shreyan, I mean, you have demonstrated part of it, but let's then talk about the lower thing, right? Like you have done the retrieval phase. Now let's talk about the augmentation and the generation phase.
Sure, sure. Yeah. So in the previous part, we just saw up till the way where we kind of did these embeddings, where we saw how a chunk is retrieved. But again, as we see, it is not in a very user readable, or I would say user appealing way. It is still readable, but it is not very appealing to me because it is giving more than what I want. So now the lower half of what diagram Vinayak was referring to. So we will look into that. How do we kind of do it? So encoding model, for now what it has done the job so far is that it has encoded our query into that particular number. It has gone to that particular database, the ChromaDB that I had created, and from there it has gotten those values that I showed, like these values has been flown back, and after that it has again reconverted them into my user readable format. So far this has been done by my uh, generation model, right? So sorry, embedding model. Now the role comes for the language models. It can be phi, it can be GPT-4 or all those. How do we stitch them together? Like how do we kind of convert this into an application is what we will see now, right? So again, I'm using LangChain OpenAI, right? This is what I'm doing. I'm using the Chroma vector store, and then I'm using the chain chat prompt template, which I'll talk about in a while. Then I'm also using some more uh, things from LangChain, which I'll talk about in a brief when I'm going to that section. This is helping me to get my env file. I'm kind of loading my env file, and I'm importing my OS, and I'm having these OpenAI embeddings that will work for my client, right? So now I'm getting my env file here, and I'm kind of loading my GitHub token. It's the same as we did before. And then we also have the endpoint, wherein I'm defining what the endpoint is, how do we do it, and all those things. What is my inference endpoint is what basically I'm doing here. And then here in the model name, I'm giving the model that I want to use. You can use any of these models that I just showed. You can use large, you can use small, you can use cohere as well. But for this demo, I'm using a very simple one, the small text embedding 3 small of OpenAI from GitHub models, right? So again, I've given one more use case here. If you, let's say, for example, do not want to use a cloud model, cloud embedding model, you want to completely keep it local. In that case, you can use this BERT model that Vinag just spoke about when he was talking about embedding. So this is the BERT model, or mini LML6 V2. You can use this as well to create your embeddings and use it as your retriever, right? But for now I will use the cloud-based model. So first I'll define one client who will actually take care of the communication of the embedding model. Then I will define one more client who will take care of the language model. So be very mindful in a retrieval augmented generation scenario. You will always have two models. One will be your uh, embedding model, second one will be your language model. So this is something that you can always keep in mind when you're working with RAG based scenarios. So for this model, I'm using again OpenAI embeddings as my client, and I'm passing my token and model and the base URL. Then the next part is what AI toolkit handles for me, right? So I'm using again chat OpenAI, in which I'm giving the base URL as this. API key is actually not used in this one, in this particular client, because it is hosted on my local. If you are hosting it on your cloud, then it will definitely need one, and then the model name. Now I'll just show you briefly how do you host this model as well. So you go to your AI toolkit, right, on your extensions tab, and then you can just open a new terminal, and in the ports you will have to just click on add a port, and then you can choose the port number that you want, and you can wait for this port to be forwarded. So I've already kept the port 5272 for my use case. And also be very careful while you load the model, because this is the model that you actually have to load. And I'm using this one, the 53 vision CPU, built for CPU, small, fast, and accurate, where it's locally hosted on my local machine, right? So I'm using that. So once you're done with this, do not close this window, keep it handy, and just minimize it, right? So my model is now a server on my own local machine. We spoke about this more, what port forwarding does, how does it help, in the previous session. So if you have any doubts, you can refer there. And I'm just defining my temperature and my model name again. So this is the model name, so which you will get it from the model card, right? You have to just if this is wrong, then your whole OpenAI chat connection will be wrong here, right? So be very careful when you give this model name. And then I've defined my clients. The next part is to load my database, right? Get my database ready. So in our previous demo, we just created this AI toolkit database. So now it is time to load it. So I'm just loading it. I'm mentioning which database is it, and I'm giving the persist directory, which directory, what's the name of it. So it's AI toolkit, and my embedding function will basically hold my embedding model. So that is again the text embedding 3 large. So I'm passing it here because it will handle all the decoding, encoding, and all the other parts that needs to be done. Now the next part is to get the outputs from there, right? So once it is done, how many outputs do I need? So in this case, I have taken the k value. So this k value kind of tells you how many cards does your the embedding model pulls out. So let's say initially when I told you, we said that there are chunks. So the relevant chunks will be pulled out from the database. So now this k, this parameter search quarks here. So this basically tells you how many cards are you asking the embedding model to pull it out, the relevant cards from the database, right? So for now, I've told pull 3 cards for me, right? So top three results that the embedding model feels that, okay, fine, this is very relevant to the user's query. They will be pulled out for me. So you can ideally set it to 3. You can set it all the way up to 10, but be very careful when you set it. It completely depends on your use case. So for my use case here for a demo, I think 3 or even 1 should be fine. So I'll for a safer side, I'll keep it to 3. Right. So yeah. Now, here comes a template. So this is where you have to define your prompt in this particular section. So I can say more than a prompt, it is like a context. It is like a role you're assigning to my Phi 3 model that is hosted, right? So through this, the language model, be very careful. Now I'm talking about the language model and not about my embedding model. The role of my embedding model is over when it pulls these 3 cards and hands it over to the next guy. That is our language model, right? So my language model should know how should it behave, right? So should it behave like an expert in some field, or let's say research expert, or should it behave like a marketing agent, or how should it behave, that, right? So to give it that persona or a role, what we do is we define something called as a context. So I'm defining a context here. So I'm saying you're a specialized AI agent, and who's very knowledgeable in Microsoft's AI toolkit knowledge, right? And how should it behave? I'm just giving it a, this is just like telling a kid how it should behave in front of people. So that is what I'm trying to do here. And this context and this question is where I'm passing the user's context, right? Sorry, the question is where I'm passing the user's question, and this context is where I'm passing this particular answer, the cards that my embedding model pulled out for me. So now what happens is I have how it should behave. I have given this is the context from where you have to answer, and then I'm given the thing that, okay, this is the question from where you should answer. So you can assume it like a kid who has a syllabus, right? Who knows this is the my question will come only from this particular syllabus, and I have to answer it in this particular way, right? So it is knowing it from here. That is the template. So if you want to know how do you actually write better prompts or things like that, then again there is a solution in AI toolkit. It is called the prompt builder. So you can go here in tools and you can see, for example, I had generated one prompt. So here I'm asking it to behave like a university level mathematics course. So this is a very detailed prompt, right? So if you want to learn more on this, then there is a blog available on Tech Community that I have written. So you can go and check it out. How do we actually form these prompts,
We
right? So
also
that
yeah, we also demonstrated it in the last session. So you can also go in the last session. If you've seen it, you would have seen the prompt generation that we have done in the last session as well.
correct. So we generated one with 5.4, so you can go back and definitely check it out as well. Then we have the prompt here. So basically now I'm passing it through the chat prompt template. Again, a template that is provided to me from, it's a thing that a LangChain provides. So again, these are all coming from the LangChain, right? And then I'm having uh, creating a runnable parallel object. Again, this is created in order to run multiple tasks in parallel, right? So one way it has to do one part and the other way it has to do other part. So as I initially told you, it is not very easy to get these moving parts together when you're generating a, or I would say when you're developing a generative AI application, and that is where your LangChain helps you, and this is how it helps you, right? So for example, here it is able to run multiple tasks in parallel. So here I'm passing it again, and finally I'm defining a pipeline in which it does, right, where each component processes and passes the result to the next component. So for example, the first one is the retrieval, right? So I've given that, then it goes to the prompt, then it goes to my model, and then it comes to the output, right? So this is a pipeline it is following. So initially, if you say in setup and retrieval, what happens is your embedding model does the job. Then you have prompt that we have defined through this chat prompt template, right? So it is a thing where the prompt is better passed to a model in a very efficient way. right? So that is happening here. Then I'm again passing it to my model. So which model is it now? It is no more embedding, but it is the phi3, the language model now. And then finally the output parser. This is for me to visualize the output. So now I'm just putting a query here. I'm inputting a query now. I'll just do that when I'm doing the demo. And then I'm just invoking this chain, right? So what does this chain invoke now? It invokes that whole process, right? So from retrieval and augmentation and generation, what Vinayak just explained the flow, this chain handles that. It first retrieves, then augments, and then finally generates it for you, right? And then I'm just printing the response. So let's just quickly run this application and see. So again, it is a terminal application I'm showing you, but feel free to go ahead and use Streamlit or Chainlit or any HTML, CSS, JavaScript
Can
code
you
in the front end.
can you
So
increase the font size maybe just to control plus plus so that people can read the output?
okay.
Yeah.
Okay, so now I'm inputting the query here. It's asking me to input my query. So I will ask what is AI toolkit. So now when this Phi3 was trained, there was no AI toolkit, right? So ideally, if I had directly asked this question to a Phi3 model, then it would have hallucinated. So the 2 points that Vinayak covered, the knowledge cutoff and hallucinations, you can see how is it controlled here, right? So I'm just doing that. What is AI toolkit? Now what happens is now it is running this chain, that chain that I had defined here, right? So it is done. Okay, so it was pretty fast this time. Okay, so the AI toolkit is a extension that enables users, and you can see that it has come up with a very beautiful answer. Let me just copy paste that answer somewhere in a notepad. I think it's hard for us to read it there. Yeah, right. So yes, zoom it in. Yeah, so it says AI Toolkit is a Visual Studio Code extension that enables users, and you can see how user appealing this particular answer is when compared to the original chunk that we had got in the previous section, right? So let me just show that this section, this is the same chunk that is being used to get the response that I'm getting it now, right? So you can see how beautifully it has formatted and given you a very appealing response. So similarly, if you want to add sources, right? So I told you that we also get sources in the metadata. So if you can see here, it says that this is the file path, and you can append this. Now why is it necessary, right? So to ensure that your LLM has not hallucinated, and to give a confidence to your users that yes, it is an authentic thing that is coming from this particular source, right? So it says keywords, date, and everything, but usually it is a good idea to provide this particular metadata, the file path or the file name in your answers, right? So you can modify it with that. So this is how you kind of perform the RAG on a using the embedding model and the language model. So that was a short demo for you, and you can find this code and everything on the GitHub repository. Vinayak, anything to add on to this?
No, nothing to add on. I think we can maybe take questions while I, put up the slides also. So Rashmita, if you can just move to the next slide, and then we'll take the questions at the end. So these are the resources that you can look at. We have all of the links that you can do. So you can take a maybe like a screenshot, or you can just go to all of this AKMS link, including the all of the detailed discussion that we've had, that is there in a blog post also, right? Like you can bring your own models using Olama. We covered reasoning models last time, and we'll cover multimodal apps next time. But this specifically, the third link, building RAG applications in Phi3, you can read more. Or if you want to share it with friends, you can use that, and you can look at AKMS/RAG Phi3 and help that. This is, as I said, like those who joined late and missed maybe the beginning. This is like third in a 6-part series, and we talked about how to work with embedding models and building a RAG application, and then you can scan to register if you missed any of the other sessions, or you want to attend the future sessions. The playlist also has input by Rashmita in the chat, so you can look at the other sessions as well, right? So next time we are going to cover multimodal support and image analysis, and we are going to build an app that kind of uses the multimodal capabilities of SLMs as well. So Rashmita, maybe we can take one or two questions that I've seen.
I think mostly it's already been answered, but then uh, Chachim, I think he wanted the GitHub link, which I just shared in the
Yes.
chat.
Yeah.
I think,
I think there was a question about ETL processes, right? So ETL processes can be
yeah.
integrated because anything that is new, that you can actually use it for data set preparation, right? So all of the embedding model and vector, putting it in the vector database can be part of ETL, right? So constantly your ETL process running, and hence your database is always constantly updated as well, right? So yeah, this is the event code. If you have any feedback for us that will help us improve the series, or any specific topics that you want to hear us talk about, if you can just give us feedback, that would really help. I hope this was useful to you. Sriyan, any other maybe last observations?
No, Vinayak, nothing from my end.
Cool. I hope you enjoyed this session, and we'll be back again in 2 weeks, as I said, with multimodal support and image analysis. And we'll talk about how do we work with images, how do we work with text, and a combination of both. And that will be really exciting. So I hope to see you back again in 2 weeks, and hope you enjoy this series. Thank you very much.
Thanks, everyone.
Thank you. Thank you, Shreyan. Thank you, Vinayak. Thank you, everyone, for joining us.